3 drinks. You will just point to because a zeroth drink, right? Done. Now, retrieval of data as fast as we can is what we need to address. So that's why organizing a data, because we have to get the data as fast as possible. And linear data, when I call a data to be linear, the very meaning of this, see, this is how you have to define. Because a company in an interview, he would ask you, how do you define the linearity? Then you cannot just say a statement from some book or a journal, because everybody is going to say the same. It will be by rot. Even if it is right, it will be by rot. So try to explain that in a more lively example, so that it is more pleasing, convincing, and correct also. So what do we do? What is linear data? You have already seen, even for a single variable, the data is always stored in linear locations when I am demanding memory. Similarly, here linearity can be established by the sequence of locations or by means of points. Now, what does that mean? Sequence of locations is like your single variable or an array variable, where all the elements in the array variable, at least because I'll have multiple data here, so all the elements are stored in the neighborhood locations only. If the first location is stored at 2000, next element will be stored at 2004. Right, because first element will occupy all the 4 bytes. But then when I check with points, how do I understand this? Suppose you are storing your biodata file on a disk. So how is disk understood? Understand that as a grid, a two-dimension matrix kind of thing, and you are finding a free location somewhere, okay, and you are just storing the data there. So if at all that block is say 2 KB, 2 KB of your file is stored there. Once you store there, what happens later? Multiple requirements of storage will come, and the locations around your file are just filled by some other data. After a week or so, if you want to add more things to your biodata, probably you have done some competitions with some prizes and all, photos and all, so you just wanted to include certificates, many things to your biodata, then the file size is bound to be increased. So when it increases, it cannot go beyond its location, because it is limited to 2 KB, and the surrounding locations are already packed by something else. So what does a disk manager do? It will quickly check some other location, free location, and allot that to the same file. So the part of the information that you have stored so far is just there, and the remaining information is stored at some other location, and that location address is stored in the first fragment at the end. So that is called as a link. Your data is still linear. The data in the file is still linear, but then you will just be able to navigate to the next one by means of links. So either by means of sequential locations or by means of links, you are going to establish a linear data. And how do you define the linear data now? What sort of data is linear? You start from a location and keep on moving. By the time you reach the end, you say that all the elements are traversed for guarantee, and you call that as linear data. So in a linear data, you can give every guarantee that you start from a location and keep on moving. By the time you reach the end, that will be traveling all the elements. You have touched all the elements. But then there is one more thing. Whenever there is a linear data, a data that has something in linearity, then at the end you have to specify the end point, the null point. For all the data that is linear, you have to specify the null point. For example, if you have a file, as you have seen in the case of storing in the disk, what happens if I store the file data in multiple locations like this? So every fragment of data of the file will have the address link for the next fragment. It keeps on going until the last fragment, and the last fragment will have the end. You call it as EOF, end of the file, which is null. In the language of file, you call it as EOF. So wherever there is a linear data, you check with data communications also. When you are passing a linear tracer, transmission of a linear data, you will need a tail pointer. You will say a pole. You will say an end at some point and say this is the end of the transmission. So wherever there is linear data, that's there is an end point. Now let's check the need of an array. Before going to that, let's list out the basic logics. I am not going to discuss the very basic logics, hoping that those logics are known to you. So I am not touching them. We'll just go with the required ones. Fine. So if you have a doubt somewhere, or if you think something should be covered or something is missed, just let me know. We'll discuss everything. You need to know the array subscript, the term array subscript. You should be knowing array notations. I'll show array notations anyway because that is significant. And then read and print elements to an array. That's a very simple program. Kindergarten, probably you know it already. And some of the elements of an array, probably I'll not discuss them. If time permits, we can show you the codes, and then I'll just display a few things, the basics here. You can just read them. Don't you don't need to write it. Yeah, subscript will be discussed. Fine. So now let's discuss these two things then, subscript and array notation. Let's see now. If I'm working on an array, you're storing the elements in linear locations, that's for sure. And one of the ways to give the values are like this: 10, 20, 30, 40, 50. And then I'm storing that in an array. And a subscript is like this. A subscript is called as an index. So the way you identify the element is quite different from the way the compiler identifies the element. Compiler always goes with the base address. If you have not updated the attendance, please quickly update it, because the attendance links will close. Uh, so parallelly, you can just fill in the attendance also. Fine. So if you have this value, the first value, you start locating that by zero. Index is zero, but then the compiler understand this as a machine address, so it will just go with the address, probably 2000, 3000, something. So it goes with the address here. And for us, we just represent them with 0, 1, 2, 3. So that's the basic way of indexing them. And when you under declare an array, like if the array size is 5, 10, 50, something, and if you under declare, like you give only 2 or 3 values, then the remaining locations are by default 0. Okay. And when you over declare an array, if it is 5 and you give 50 values, then compiler will throw an array. It doesn't understand what to do. And if you just have some random number of values and you don't specify this size here, it automatically defines the size. It will just count the number of elements and it decides the size here. Done. So subscript is only an index. Subscript is a way to identify these elements here. But then when it comes to the memory, look very carefully. I tell you, arrays, pointers, and strings will go hand in hand. You cannot miss even a small bit in this. This is highly significant. Check carefully. A is equals to 10. Then what? I'll have this single allocation, which is A, and I'm storing 10 here, right? Done. Of course, it is stored in bits, but for our convenience, we take this like this. But then I'll have the address location also, 2000. Just as an example, it can be any address. Now there are two reference operators, or you call it as indirection operators. Be very careful with them. We have to understand like this. Single instance variable. What does that mean? A single instance variable is a variable that is pointing to a single data, like a normal variable, other than array variable or any other variable that you know. Just a variable that points to a single value. We are calling that a single instance variable, and this is pointing to 10. So by default, wherever in the program, if you use A, you will be substituted that by 10, right? So 10 is given there. That's perfect. And then usage of ampersand will derefer that from wherever it is pointing to and goes to the address location. Remember this carefully, because we are working with ampersand. Ampersand is a dereference. It goes down back and prints checks with the address. So ampersand is an indirection operation. It is going to the address, and any other reference will by default refer to address. What do I mean? If it is not a single instance variable, for example, if it is an array, array by default is pointing to the address. It doesn't point to the value. So when something is pointing to the address, what do? You use a star in order to make it derefer and point to the value location. So there are only two types of indirection operators here, ampersand and star. Ampersand will point from value to address, and the star will point from address to value. It can be any reference now. So the statement is very open now. You have ampersand and star. You feel free to use them in any fashion. Only take care that after ampersand it should be a value reference, and after star it should be an address reference. What does that mean? If something is pointing to an address, star and that something will derefer to the value, right? So after ampersand I need value reference in order to go to address, and after star I need address reference in order to get the context. Fine. Now let us check the notations part. The notations are extremely significant. If I have the array, so the subscript is 0 to 4. You have the 5 also. I'm just ignoring that because that is null. You need to have the entire section. So if I declare the array size of as 5, it's a whole number 5. It's never a natural number 5. A whole number 5 is actually 6 elements, right? You include 0 also. So from 0 to 5, but then the last element is just ignored because last element is not an element there. That's just specifying the flag, end flag, null, right? Done. Now the value representations, if I want to represent say 10, how would I do that? I can write a of 0. So a of 0 means 10, or 0 of a. This is perfectly valid. People write, see, this helps a lot while you are working in a small program. For example, if you are in an interview and you are writing a code where you expect that everybody will write it, then what can you do? Instead of writing a of I, you can write I of a or x of a, whatever. What does that do? That will make your code distinct from plagiarism. Even if you are having an idea, you suspect that the same idea used by everybody, so you can just change the way you work with this, because this all is exactly the same. So a of 0 or 0 of a, or you can just substitute the variable here, a of I or I of a, both are exactly the same. Similarly, now comes the crucial point where a is pointing to the address, right? And star will derefer. After star I need address reference, right? We have just seen. So after star, if I have address reference, then that will refer me back to the value. So I can give star a plus I or a plus 0. 0 means the first location. I can iterate from 0 to n minus 1 locations, right? You know that. So a plus I or star I plus a. Both are exactly the same. It's common sense that I write a plus 0 or a 0 plus a is the same. But why do I specify the second one is only to counter plagiarism? If you are writing a code and you suspect that everybody is going to write similar logic, then you make your code stand apart by using one of this, not going with the very common one, so that you escape plagiarism and it looks a little different. Fine. Moreover, this is value representations, and all these four are substitutable for each other. Okay. And when you check with location representations go like this. We have a query. Harshit Singh wanted me to just repeat this once more. Let us just quickly look at it here. See, what did we say? An ampersand will derefer from value to address. So if I give ampersand A, what does that mean? I am not referring to 10 anymore. It is ampersand 10 and going to 2000, right? And then when I have a star, if I am referring to 2000, okay, so star of 2000 will derefer and get me the value part. Star always gets the context and ampersand always gets to the address part. So now let us check here. If I have an array, excuse me, So from 0 to 4, I have all the locations and I have these values. As an array, say if A is the name of the array, A is by default pointing to the address. Why is that pointing to the address? Because we have seen that anything that's not a single instance variable, any other reference will by default point to address. So if there is an array, it's by default. And instead of A of I, write it as A plus I with a star. It's all the same. So whatever you obtain by A of 0 or A of I, you can obtain with the remaining three also. Fine. Hope that is clear, Harshit. Then we'll check with the address references now, the location reference. Fine. So what do you mean by this? Whenever I am representing the location, do I really require to represent a location? Yes, you require. Why? Because if I want to store value here, don't you write an ampersand? Ampersand of A of 0, ampersand of A of I, right? Address of A of I. What does that mean? You are dereferring from value location and coming to address location. 0 of A is as good as A of 0. See, these two are exactly the same. Somebody just asked me what is 0 of A. See, at a 0th location value or at 0th location value of A, it's all the same. It's only like active voice and passive voice. In A, 0th value or 0th value of A, it's all the same. You can just write it in uh, uh, a plain English like this. Oh, sorry. So A of 0 is read as uh, of A 0th element. And if you write it as 0 of A, now you should read it as it just as a passive voice. It's 0th element of A. Fine. Okay. So hope that's clear. So those are value representations. Let's check with the address representations. There is a small difference between the languages because I just got a query. I would just like to address something. Uh, Languages will either give you a facility to manipulate the memory or the languages will not give you. Be very cautious. The languages that give you facility to manipulate the memory, okay, those are structural languages. So this will be common in all structural languages. Other languages that are not supporting the memory manipulation by the user, you have to check the case. But this is a valid one. Like, you may have a different representation, you may be working with Scala, you may be working with some other, but just concentrate on this case for now. And because you get questions exactly the same, and you can just write codes also in the similar manner to avoid the plagiarism also. And then the location representations go like this: address of A of 0 or address of 0 of A, it's all the same. But when it comes to A, I'm not running ampersand. Why? Because A itself is an address already. A is not a single instance variable. So A by default is pointing to address. Because A is address, I use star in order to get the context. If I don't use star, it is representing the address already, right? If I am not using star, A is representing the address already, and I don't need to give anything to refer to the address because A is an address already. So A plus 0 is as good as A, this location. A plus 2 is moving to this location, right? Or 0 plus A. So instead of writing an ampersand A of 0, you can just write A plus I. Okay, ampersand is not needed in a scanf. You can just give this. That will be working good. So you have this 8 representations when it comes to array. Array notations, all 8 notations here. 4 notations for value representation, and 4 notations for address representation, which is location representation. Now hereafter, we'll just go do a just overlook on all the simple logics. Then we'll go to a pen and paper question. So the very basic logic is you just take the independent element. So you have to specify the element here like zeroth location, two location, or I minus one location, because zero is first element, two will be the third element, and I minus one will be the ith element. Very good. If I am moving very faster, please tell me. I am assuming that this is common sense. We know this. So, in order not to bore you or not to get you the same knowledge again, which you already know, I am just moving a little faster. So, array name and position number. Very normally, you give the name of the array here and the position number, but you already know in array notations you have seen, you can just interchange them also. And when you are working with array elements, when you specify along with this value reference, they behave just like the normal variable. C is not a normal variable. C is pointing to address, but C of 0 is as good as an integer variable. And you can work general subscripts also. Like in the subscript area, you can give an expression, and all it checks is whether this gives a proper subscription to a index value or not. So 5 minus 2 is as good as 3. So you are allowed to give expressions here. And then while declaring the array, you have to specify the name, type, number of elements, etc., etc. So assume that we know this. So you have initializers, as you know. I can give initializers and give this value. Otherwise, if I under declare, then all the values will be zero in this. It's not zero because I gave 1 0 or everything is zero. No. In that case, if I give 9 here, then all elements should be 9. It's not like that. The value that you declare will be stored explicitly, and remaining values that are not declared here because you under declared the array here will be by default zero. So a zero will store everything value with zero. If it is given 1, then not every value is 1. Only the first location will be 1, and remaining locations are by default 0. So if not enough initializers, the rightmost elements will become 0. That's good. And of course, this is one part. C and C++ don't have a strict checking for bounds of the array. And when you want to find the max element in the sequence of numbers, you probably need an array. But then without an array also, you can work on this problem. How? Because all you want to find is max element. So just run a loop and every time scan a number, keep max to the first number, and thereafter check the max with every number that's coming. And if the max is any lesser, update the max. Done. Why do we need an array? We don't. But do we really work without arrays? Is array not very significant? It is. For general example, if I want to find the second max, then I need an array here. And how am I doing it now? So one can argue that you don't need an array also for second max, so probably for third max, fourth max, k max. So if I keep on moving like this, where is the end for this? You cannot go and stop at some location there. So you should be cautious. Fine. So I'm just having an array, and if somebody is looking at this limits.h, you can include this. Limits will specify the int min and int max, because your logic is compiler dependent when it comes to sizes and ranges. You don't know what is the integer limit on a compiler, on a random compiler, because you are working on online compiler. You don't know if the company's compiler is checking int for 8 or 4 or 2. Different compilers will specify different things. So for that, what do? Is we just declare an int min here. What is int min? Whatever is the minimum integer number possible on that compiler will be stored in max1. So int min. And then max2 is also int min. So initially I am checking the first two max values because I want to find the second max. So I'm just storing int min in them. Case maybe if I have a minus number that is the minimum limit on this compiler, so that value is already there in max1. Done. So what does this ensure? This ensures that whatever the value I get now, even with 0, will be max than this anyway. I don't hope int mins very normally. So I just declare them to int min, and post to that I equal to 0, I less than n, I plus plus, and a of I is greater than max 1. Now, what does that mean? A of I is greater than max 1. I'm just taking this array and checking the value with max 1. Obviously, 1 is greater than the int min, right? So, int min will be a negative number anyway. So, what should I do now? First, store max 1 into max 2, because the current max will be second max now, because max is updated. So, I have to update the second max and max here. Then max 1 equal to a of I, perfect, and else part. Why else here again? Because if it is not, then I have to check for the max 2. For example, if the max 1 is say 20 and max 2 is 5, max 1 is 20, max 2 is 5, and the current element is 15. 15 is not greater than 20. So I cannot just skip it. I have to store that as max 2, because max 2 is 5 and 15 should be the next max, right? So in the else, I have to put a condition. So directly don't put else here. A condition where if this is not greater than max 1, probably the value is greater than max 2. Check there. And here you can directly update max 2. No change in max 1. Done. So once you finish this loop, you have the max 1 and max 2 handy, and you can just print the values. Done. But then we can write this without the array also. All you have to do is just write a scanf statement here, right? Done. So we can work without an array also, just like this. But then you can't just go on doing this for any big value, like for k numbers it will be highly impractical to manage that many variables, and that's why we need an array. Only for a second max, then there is a design flaw. You don't need for a second max or first max, we don't need. But if you just keep on having this, then that will be a problem. Fine. So we need an array. And then of course I'm just running through these programs. This is reading and printing elements. I'm not going to explain them, assuming that we all know this logic. So if at all any explanation is needed, you read the heading and please ask me. Otherwise we'll go to the pen and paper question. So this is some of the array elements. I'm just writing some here. I could have written this here with a bracket here. Done. And max and minimum element in an array, how do you find it? Initially, the first element is the max, first element is the min, and I check if min is greater than a of I, then min equal to a of I. Minimum value should be lesser. If it is greater, then update min. Otherwise, check if max is less than a of I. Max should be greater. If it is less, then update max. Done. By the time you finish this, you have min and max at hand, and you can print them. Good. And searching an element of in an array, that's very easy. What do? You do is you just increment the flag. Excuse me. As soon as you find an element, you don't go and you say print found or not found. You know why. So we just work with the flag here and move, right? Good. And insert an element, a very interesting question. I want you to write the code. So don't take this code here. Code is accidentally displayed. I just wanted to give this as a homework. So when on an array, if I'm inserting a value, all the values should be moved to right side, and you should insert them properly. Similarly, a delete element. So when I'm deleting an element, all values should be moving to left side from the position of deletion. So that will be your homework. You can work on that problem. Odd and even elements is a very crazy program. Simple. Check if it is an odd number. Print all the numbers. Odd even numbers will be printed at one side, and all odd will be printed at one other side. Good. Reversing an array is quite good logic, but very common. Not like very basic logic. Okay, Rishi Singh wants me to go a little slower. Very good. Anyhow, I am going to slow down because this is the last common example that I am going to give, and then there will be a pen and paper question. When we work on reversing an array, what do? We take 2 pointers, and 2 pointers, two indexes, index pointers can point to the first and last element. So you can just take the size and declare that many elements. into the array. Done. Once taken, what do? J equal to num minus 1 and I equal to 0. So I points to the first element in the array, whereas J points to the last element in the array. Num minus 1, observe, because num location will have a slash 0. So num minus 1. And now what do? While I is less than J, just keep on shifting the values, swap the values of I and J. So first value is at the last value is at the first. Then go to the second value and second last value, third and third last value. So if you keep on doing it until I less than J, by the time I reaches half the way, J has also reached, right? And your array is reversed. So you can just print the array at the end. So these will be the basic logics. Even if you know them, have a good practice on them also. And let's go to a pen and paper question. Now the question is, you are given a binary array. Do it in your book. Shift all zeros to one side. So you have a binary array. What do you mean by binary array? Randomly scattered zeros and ones in the array. You have an array and you will have all zeros and ones there. You don't know the order. You can just have some zeros, then some ones, some zeros, 0, 1, right? I want to shift all zeros to one side. Write the algorithm, the basic logic for this. How do you do that? If you have found the logic, you can just give it to me. It's an array. It's numbers 0 and 1. If you just go to reverse the array, then please check, because you cannot just reverse like that. Mm, Someone has got an idea to sort the array, but then sorting will give you the time complexity greater than n. So don't go to sort. Someone has given Shobit, you are right, but you don't need a new array. You can just do that on the same array. Good logic, quite good logic. Yeah, good logic, Dhruv. And then update current area, that should be array. Fine. That's true, but you don't need a new array. Like all the people who are taking a new array, you can just work on the same array. For example, let us look at a logic here. Say method 1 is to count all zeros or ones. So that should be pretty easy, right? So you can just run, yeah, that's good. Some people have given a really good implications. You can just count the zeros or ones. Now count the number of zeros. Let the count be the count. Then what do? You already know how many zeros are there on the array. So what should you do? Put count times 0 from the beginning, and remaining locations you can put 1. Finished. So that will be a simple method. You are doing this in order of n now, right? So int main, and you have the array, just a random array. You can have elements in any scattered fashion here. Then what do you do? Just count the zeros, and then place all the count locations with 0, and from count, because when it reaches count you are stopping. So from count you start, and until less than n you can fill it with 1. So that's one simple way of printing it. So if you don't understand what is cout, take a printf here. uh, C or C++, that's the only difference here. That's what I said. Like when you look at the IO, you will find that this is belonging to another logic. Otherwise the logic will be very common. Now think of the second method. Somebody has already given the second method, but just keep thinking. I'll show you the second method soon. Don't sort it. Yeah, you can swap. Sheesh. Mm, probably good answers. Then how do we do that is, let me show you this logic here. Yeah, like reverse logic, Aish, you are right. Most of the people are right. They have given good logics. If I read everybody's name and the logic, then it will eat up the time. Because everybody has a good idea here. Yeah, maintaining 2 pointers, maintaining 2 indices, that's perfectly fine. What do we do is a 2 index one. So you can take 2 indices, 2 pointers. Left pointer will be initialized to 0, and right pointer will be initialized to 1. Then what do you do? While left is less than right, what should I do? Check the left value. As long as the left value is 0, keep on moving the left. So first you found one, left stops here. Then you shouldn't do anything with the left. Leave the left here, check with the right. As long as it is 1, keep on moving. The first instance of 0, stop. Then swap 0 and 1, right? And then left should move and right should move. So you can just repeat this. And while left is less than right, you have to do. Why this condition? Because if left has already crossed right, then they are already in the order. So you don't need to make any changes. So let's check here. I have a binary array, and left equal to 0, right equal to n minus 1. Then left less than right. Okay. What do I do? Even if you are seeing a nested loop here, it is not order of n square, because I am not going to touch the element more than once in this array. So all the elements that I am going to refer is only once. So this cannot go beyond n. Let us see what. I have a while loop here, but I'm navigating here until I find the first one. Otherwise, if a of left is 0, then keep on moving left until it is less than right. Now, once you reach right, you don't need to do anything, because you have, if the array is say all zeros, then what do? It is already intact. You don't have ones. If you have, then you have to move ones to the other side. Otherwise, it's all zeros. That's true. So left plus plus, as long as you are moving on the array, if you find 0 and you are still less than the array size left, then check with the right. If your array of right is 1, if it is 1, you can keep on moving until it is 1, from right side to left side until the first encounter of 0, and until left less than right. If it is already crossing left, then you don't need to move at all. It is already intact. So left plus plus and right plus plus. Then if left less than right, okay, if left less than right, what do? Why left less than right? Why should I check this? Assume this case, if I have 3 zeros here and 3 1s here, what happens? Left will move on and reach here and stop, right? and right will move from here, and it may stop here or it may stop here. But one of these cases, when it is crossed, I should not swap the value. So I just check if left is less than right, only then I make left is 0, right is 0. So no need to swap also. You don't write the three liner logic, because all the numbers you have is 0 and 1. So left can be turned into 0, right can be turned into 1. Done. Then left plus plus, right minus minus. So once this condition is done, then check if it is still left less than right. Like at some point you stopped and you swap. What about the remaining values? So again, check if left is still less than right, then just navigate. So repeat this logic until they meet each other. If they meet, then you are ensured that the array is already sorted. Sorted is like with zeros and ones. Okay, fine. So you can quickly write down this logic. We'll go to pen and paper question one more. Fine. Hopefully, we have taken that logic. Now, let us look at another array here. We call it as a two-dimension array. Now, a two-dimension array should be looked at altogether with a different kind of insight. We are leaving the basic problems anyway, like the basic navigations. Every data structure that you are going to see hereafter will have these things. What do you mean? You will have the basic problems. Basic problems are merely a traversal problems. So that is what is traversal problems. What are traversal problems are the insertion, deletion, updation, searching. All these comes printing the values. So all these comes under basic traversals. So those are the basic problems. After that, you will have classical problems. So classical problems are the problems that are non-trivial problems, but they are not the coding problems yet. They are just making you to work on that data structure in a more efficient way. So if you can solve classical problems, you can claim that you know that data structure. With basic problems, you cannot say that you actually have a good hand on that. Probably you just know them. But classical, you really can work with that. But then you will have something called as coding problems. Then coding problems is where you are implementing them. So if we know the basic problems, that's really good, required. But we have to work with the classical problems also in order to boast that we know that data structure, without which we'll not be able to work at all. And if you are good at classical, then you can do the implementation in the coding problems. So let us look at this. There are a little few classics on this. When you work with a two-dimension array, that's a simple matrix like a spreadsheet. Okay, so I'm just going with the basic definitions first. We'll just move on and we'll go to the problem statement first. You can just look at the two-dimension array like this, and you will have indices as good as you had the matrices in your high school. So 0 1 2 3 0 1 2 3, that's perfectly fine. The first representation goes with the row, second representation goes with the column. And 2 by 2 is 2 rows 2 columns, and 3 by 4 is 3 rows and 4 columns. Right, done. Hoping that we know this. And a two dimension array implementation can be done like this. It's a list of one dimension array, and every one dimension array can point to a separate one dimension array. So this can be a two dimension array too, based on the compiler. The list of basic logics one might require here are these: read and print two-dimension array elements. This is pretty simple. Transpose of a given matrix. So probably you can do this as your homework. These are really simple problems, but very efficient, because you will be using these logics in your near future. And then matrix multiplication, of course, and diagonal display of the element. That's a really good display, only the diagonal. So think, how can you do that? Then sum of each row of the matrix, a very good problem, and sum of each column of the matrix. So this will be a general quick warm up exercise for you. Other than this, we have some coding problems here on two dimensional array. Of course, this is not this is a simple navigation problem. Like you just have the array and you are printing it, so you try scanning and printing them. When it comes to two dimension array representation, here is where we are a little interested in. Now, observe carefully. What did we say was, your memory manipulation or the memory manager works like this. Like what? One demand and one serving, right? What does that mean? If I write an int a, all the four locations are given in the neighborhood. If I write an int a of 6, then all these locations are given in the neighborhood. So implicitly, every demand is looked at independently and it is served in one single sequence of locations. For example, if I have a comma b, now this is not one demand. Comma is a separator operator. It is as good as writing int a separate demand, int b is a separate demand. Two are two separate demands here. So there is no guarantee that a and b will have sequential locations. You will get A, but then B is not guaranteed to be sequential. It may or may not be. But when I am putting up a demand like this, then this is sequential, because all five locations are demanded at once. Now, observe carefully. If I have an array of 4, we know we get 4 sequential locations, right? Good. If I put up an int A of 2, now this is a single demand, so I should get 4 sequential locations. Okay, so the array that gives me 4 locations should be valid. So this is an array of 4 locations, which is representing array of 4, which should also represent array of 2 comma 2, which is perfectly valid. Why? Because when it comes to memory, a two-dimension array is an illusion. There is no two-dimension array. It is a single dimension only. It all depends on how we store data there. So when it comes to memory representation, I am speaking only strictly with respect to memory representation. A two-dimension array is merely an illusion. You don't have a two-dimension in the memory. So how do we store the data? This is the matrix I have, which is 3 rows and 4 columns. Now, if I want to store that, I can store it as 865421973642. So I can store row by row. So you can store it in row by row. You call it as row major order. And you can store it as column wise also: 823616594472. So that's column major order. Your compiler, it's purely depending on your compiler how you store the data. You can store row by row and you call it as row major order. You can store it column by column and you call it as column major order. So there are two types. Your Python stores in column major order, and C and C++ languages store in row major order. You have to check with the compiler in order to know how is it stored, whether it's storing in a row major or is it storing in column major order. Fine. Now, what do we do after this knowledge is, if I have a two-dimension array representation, index is starting at 0 in this case, and if A is m by n array, row and column, and I have some base address. Base address is the first address of that allocation. And if I have a word length is the size of the data, size of each element. If it is an integer, then 4. If it is a character, it's 1. Right? So in that case, if I have a word length also, then if I am storing row by row, a row major order, and I want want to find the location of an element. If the first location starts at 200, the second location should be 204. I want to know what is the location of ijth element. If I am storing row by row, then this address differs from column by column, right? So A of ij is equals to the base address plus the word length multiplied by n into I plus j. Now, why is this n into I plus j? What is n here? N is the column. Why am I using column at the place of row? Check very carefully. If you are storing row by row, you need to know the number of columns in order to break it. For example, if I am storing 5, 6, 7, 8, 9, and if I know that the array is like this 5, 6, 7, 8, and 9 and 1. Let us say I have one more here. I did not do it equally. So 1. If I know the column size, I can break at the column, right? So after 2, because column size is 2, after 2, my array is different. So I know this. So to break in column major order, I should break with the row. In row major order, I should break with the column. Because this is storing in row major, I need to know the column. So check in this. Because I am storing row by row, I need to know the column size and break that with the column, and you will get the address location because you are adding base address location to this. And when you store by column major order, guess the value now. Column major order is column major of for A of ij base address plus the word length of row into. When you are working with row, you need to know column to break. When you are storing column by column, you need the row number to break. So with the row number, I break and I find the location. So I'll give you this as a homework too, because you have 2 more days to work. So lot of homework, but really good homework. It will give a good insight. I strongly advocate, recommend to do all this. Uh, Take this and substitute some row and column number here. Take some base address like 100 or 20, whatever, and take one word length, a valid word length like integer 4. And then try to substitute those values here. Don't give values to I and j. Just only substitute this value. You will come up with an equation. And there will be really good understanding there. So for now, I think it's